Thank you for joining us for our panel discussion, Design Writ Large, Design Arguments, Design Detection, and Natural Theology. The Evangelical Philosophical Society is pleased to welcome the following panelists. Dr. Douglas Axe holds the Rosa Endowed Chair of Molecular Biology at Biola University, where he also co-directs the Stewart Science Honors Program and serves as an advisor to the AI Lab. He is a senior fellow with Discovery Institute's Center for Science and Culture, the founding editor of the journal Biocomplexity, and the author of Undeniable: How Biology Confirms Our Intuition That Life is Designed. Dr. William Dembski is a founding and senior fellow with the Discovery Institute's Center for Science and Culture and a distinguished fellow with the Institute's Walter Bradley Center for Natural and Artificial Intelligence. He's the author of the Design Inference, which was a landmark of the intelligent design movement, published in 1998. The revised and expanded second edition, co-authored with Dr. Winston Ewart, was released in 2023. Dr. Bruce Gordon is the professor of the History and Philosophy of Science and instructor in logic, mathematics, and science at St. Constantine College and Upper School, and a senior fellow with Discovery Institute's Center for Science and Culture. He's widely published in philosophy of science journals, has contributed essays and chapters to several edited collections, and authored the appendix on inflationary string cosmology in New Proofs for the Existence of God, Contributions of Contemporary Physics and Philosophy by Dr. Robert Spitzer. And Dr. David Haines serves as an assistant professor of theology and philosophy at Bethlehem College and Seminary and is the founding president of Association Action, the Association of French Evangelical Scholars. The second edition of his book, Natural Theology, A Biblical and Historical Introduction and Defense, was released in July, and his book, Richard Hooker on Natural Theology and Scripture, was just released in September. Our moderator this afternoon is Dr. John Bloom, Emeritus Professor of Physics and the founding director of the Science and Religion Graduate Program at Biola University. After we hear opening remarks from all four participants, we'll take a 10-minute break, and then Dr. Bloom will moderate the panel discussion and take questions from the audience when we reconvene. Dr. Dembski is up first, followed by Dr. Gordon, then Dr. Axe, and finally Dr. Haines.
Well, there was a book written several decades ago, Peter Bowler, Evolution, History of an Idea. I'm going to do Design Inference, History of an Idea. So this is work I've been doing well over 30 years now. And so let me just try to put it in a way where you can get an idea of the problematic, what this is all about, some of the progress that's been made on this idea, some of the criticisms of it, and where we are now. Hopefully I can get through all of this. So here's the basic problem. If you're confronted with some event, object, or structure, can you look at it and in the pattern that's there, tell that it's a product of design? So design, we think of it as externally implied information. So it's something that's being done to it. There's an intelligence that's acting. This is an Aristotelian notion. Things are designed. The art of shipbuilding is not in the wood. You have to get an external designer to put pieces of wood together to form a ship. An acorn produces itself naturally. It comes internally. So the idea of external design. So can we tell that we're dealing with a designing intelligence by looking at certain things? Now, the logic there is from effect to cause. If you see a cause that you know to be intelligent, and then you look at its output, well, you know that the output is the product of an intelligence. So if E.T., as in the Spielberg movie, comes down, you see a little green man, the little man is doing purposive things, and you know that you're dealing with an intelligence. What intelligent design, though, is trying to get at is when you don't see E.T., when you see something that could be the result of E.T., the fingerprints of E.T., but you don't actually see E.T. Well, what's that? Well, SETI, the Search for Extraterrestrial Intelligence, gives you that sort of that there you're looking at an effect and trying to figure out the cause. There are lots of radio signals, lots of signals coming from outer space. What about a signal could tell us that we're dealing with an intelligence? And if you look, I mean, this is a scientific research program, and there are these indicia, these signatures of intelligence. We even, SETI researchers will even talk about technosignatures, something that will indicate that we're dealing with a technology. So if we're looking at a signal from outer space, what are we looking for to tell us that it is the consequence of intelligence? So let's imagine that there actually is an alien intelligence out there. It's communicating in English. Just we got lucky. Star Trek, it's we think of English not just as the lingua franca on Earth, but across the universe. And so you have an extra alien intelligence communicates and says, a great day has come about in the history of our civilizations. We have finally established contact, okay? Now, that's the message that this alien was about to convey, but the only thing is, it was conveying it in ASCII code, American Standard Code for Information Interchange, but all he got out was the letter A, and then had a cerebral accident, and that message never made it. Now, those 8 bits that arrived on our end were the result of intelligence. They were intentionally sent. It was the indefinite article that was sent. A great day has arrived. And yet, no SETI Pro researcher is going to go to the New York Times science editor and say, it's amazing. Aliens have finally contacted us and they sent us the indefinite article. So the question, though, is why? Okay, it was intelligently caused, but what about that, or what's insufficient about that? Well, if we're going to tell that we're dealing with an intelligence, we need to have something that's highly improbable. There's got to be complexity there. It's not just enough to have the letter A. It's got to be a long sequence of stuff. Okay, but a long sequence of stuff isn't enough. In addition, it also has to be recognizable. And if it's just a random sequence, there could be random radio noise, which comes to us. And, there'd be nothing in the pattern that would tell us that we're dealing with an intelligence. So we need complexity, we need a lot of stuff, and we need something that is recognizable. Now, recognizable, what does that mean? Isn't that in the eyes of the beholder? Well, that does tell us, though, something about design inferences. It requires knowledge to infer that we're dealing with an intelligence. There are lots of sound combinations that could be coming out of my vocal cords. Most of them would be gibberish. Some of them might be natural language, and you would mistake it for gibberish because you didn't understand the language. So gibberish being random stuff. So we need to have patterns that are recognizable, and it's a recognition that we come to based on our background knowledge. But that's really not good enough to base a science on. So what we do with these design inferences to try to make them rigorous is we say, what makes something recognizable is if we can describe it succinctly, if we can get a short description length of it. So in the case of, let's say, a SETI message, we could say, oh, that's an English message. Now, the thing is, English message, that's a short description. If you've got a long sequence of stuff that answers to that description, there are lots and lots of bit strings that would be incoherent, that wouldn't answer to that. So it's going to be highly improbable that a random sequence is going to actually form a coherent English sequence. So what we need when we're talking about, when we draw a design inference, we need complexity and we need a recognizable pattern. And recognizable pattern, we cache that out in terms of minimum description length. So that's a big topic. There are reasons for that decision, but ends up being a very general notion. So if you've been looking at, for instance, recent origin of life research, you'll have somebody like Lee Cronin or Robert Hazen. They're going to talk about functional complexity. And the idea is that there are these things that are functional and that they're very narrowly constrained, so highly complex, but there's also a function there. Well, these functions have short descriptions. So this minimum description length approach actually is what gives us a rigorous account of the patterns that we need that in the presence of complexity give us a design inference. So let me say a little bit more about complexity, because we think of complexity as lengths of bit strings, and we can count the number of bits, but those bits can also be translated into probabilities. So if I flip a coin 100 times, it takes 100 bits to describe that sequence, but the corresponding probability there is 1/2 times itself 100 times, which is about 1 in 10 to the 30 or 1 in 1,000 billion. So that's, you get something that's highly improbable. Then if you also have something that has a short description, 100 heads, that's a short description. The thing is, we can get 100 heads conceivably by also flipping a coin that's single-headed, okay? And so what you need to be careful about is that you don't just presuppose a uniform probability. You've got to be able to actually sweep the field clear of the probabilities if you're going to draw a design inference. And so what you end up getting, what's crucial is this complexity or the equivalent of improbability, and then also to have what we can call a specification or a pattern. Now, these patterns, these short description patterns, they come in two forms. They come in pre-specifications and then, as it were, specifications after the fact. So you can think of it this way. If you have let's say that wall over there, put a target on the wall and you shoot arrows at the wall. If the target is fixed and you keep hitting the target squarely in the bullseye with the arrow, you'll know that you're dealing with a skilled archer. Okay, so by hitting that fixed target over and over again, that target sets a pattern, and it's highly improbable that you're going to do that by chance. You're going to know that you're dealing with a skilled archer. On the other hand, one thing we don't want, which would not be a specification, are movable targets. So if you can move the target, so whenever I shoot at the wall is so large that I can't help but hit it, and then I paint a target around the arrow whenever it lands, so the arrow is squarely in the bullseye, that's not going to count. Okay, so that's the wrong type of target. But the thing is, many of the targets that we find that are important to us, we come on them after the fact. It's not just that the target is given to us. We come to it after the fact. So we're archaeologists. We look around and we find a rock, and then we say, oh, there's something unusual about that rock. Oh, it's an arrowhead. So we discover a pattern after the fact, and yet it convinces us that we're dealing with an intelligence. So these design inference end up being small probability specification arguments. Small probability or complexity, I said that's the same thing. And so often what we will say is that we'll describe that as specified complexity is the thing that is that we're discovering with these arguments. So this notion of specified complexity is something that's been out there for a while. It was never really developed formally until we did it in the design movement, but Origin of Life researchers Leslie Orgel came up with it. What we find, though, with specified complexity is it is a form of information that identifies intelligence. And where this has become more interesting lately is that it provides a unique and unified information measure for identifying the effects of intelligence. And it depends on a duality between events and patterns. So an event, we can describe it in terms of a probability. So you flip a coin 100 times and you get, let's say, 100 heads. Well, we can also describe it as 100 heads. Thing is, if we coordinate the language we use to describe these events and the events turns out that bits can be used both to describe probabilities and patterns. And then the relationship between the bits that we need to describe the event and the bits that we need to describe the pattern, those actually become commensurable. And this ends up being a very powerful notion, because what it means is that we can subtract from the complexity in terms of the event complexity from the pattern complexity and get a unified information measure. So what does that all mean? What it means is, think of it this way. Any event can be described with a long enough pattern, a long enough description. Let's say, take 100 coin tosses. I can say heads, 2 tails, 3 heads, 4 tails, 1 head, 2 tails, and so on. That becomes a long description. But if I can give a very short description of that whole sequence, any sequence is going to be equally improbable, but the short descriptions ones are going to be much fewer. And when you see that, a short description of a low probability event, it's going to trigger for you a design inference. Let me give you this type of example. Poker. There are about 2.6 million poker hands. Royal flush. If I tell you royal flush, that's a short description. What sort of improbability does that answer to? It's about 1 in 700,000. If I say a pair, there are about 1.1 million cards that answer to a pair. That's about a 2/5 probability. If somebody tells you royal flush, you're going to be much more inclined to say that's a cheating pattern. There's design there than one pair. Okay. So it's that balancing act between the improbability and the specification, the short description, that gives us that gives us a coherent and powerful notion of specified complexity. One way we illustrate that, my co-author and I, he actually came up with the example, is if you recall the movie Empire Strikes Back, there's a point at which Darth Vader says to Luke Skywalker, "No, I am your father." Okay. "I am your father" is very short description. It's going to be highly improbable that anybody answers to having Darth Vader as your father if you're looking at the entire universe. On the other hand, there's Spaceballs is a Mel Brooks parody of this, where you have a Darth Vader character, I think it's a Dark Helmut, who's with a Luke Skywalker character, and this Darth Vader character there says, "I am your brothers, roommates, sisters, this, that, and the other thing. Can I, and it's such a long description. It's like with 6 degrees of separation between anybody and anybody else in the world, you give enough descriptive length, you can describe anything. So it's being able to describe something briefly and then still have something be improbable. That's where the design inference works. And what's important about this is, this is if you go to standard information theory books, for instance, Thomas Cover's book on information theory, any of them, you're going to find Kolmogorov information and Shannon information. But what you don't find in them is Shannon information minus Kolmogorov information, which is what you need to do. And that's what actually gives you the measure of specified complexity. And when you get that measure, that actually gives you also a probability, a small probability that anything could answer to an event of that description length. So it ends up being, it is a positive contribution to the information theoretic literature, and it's not in the information. Basically, the information theoretic books give you the tools, but they don't actually put it together. And if you look at the current debates over origin of life, they are grasping at this notion, but they won't admit it. And so if you go to Wikipedia, you'll find that specified complexity is a creationist argument by William Dembski, which fails to, it's just, they make sure if you've got a biased Wikipedia entry, they'll make sure that in the very first sentence, they get all the negative terminology there to discredit the idea. And the entry is also about 20 years out of date. But this is at the heart of the design inference, this notion of specified complexity, and it applies. That's what identifies intelligence, and that's what it's also going to be highly applicable in biology. So the sorts of systems that Doug Axe considers, they're going to be highly improbable even under an evolutionary scenario, but also easily described. I mean, his beta-lactamase protein fold is going to have a certain antibiotic property. It has a level of antibiotic resistance. That's a very short description. So this idea, it's powerful, it's out there, it's underappreciated. So that's where the design inference is right now in terms of theoretical development. I think it's really been nailed down in the second edition, and the evolutionists are still not buying it because they think that natural selection is a way to get around it, and it's not. But that's a story for really, I think Doug has addressed that in his work, because these design inferences don't just depend on assuming some probability distribution willy-nilly, but ignoring others. Doug's work looks at all the relevant probability distributions and sweeps the field clear from them. But there are some objections that evolutionists still make about the power of natural selection, and there's a whole line of argumentation about what's called conservation of information, which you can look up if you like under my name. So I will leave it at that.
Lots of information, very little time, and we'll see how far we can get along here. So you're probably familiar with the old definition of intelligent design as there being certain features of the universe of biological systems that are the result of an intelligent cause rather than an undirected natural process. And we want to take a look at how that applies to the question of fine-tuning and cosmology. All right, so what is fine-tuning? Well, we can think of it in terms of the initial conditions, laws, and constants of nature being in a narrow life-permitting region in comparison to the theoretical range over which they might have varied. And we need to try to give some precision to that, and that's going to require putting certain things in the background and bringing other things to the foreground. In terms of making a design inference, I mean, Bill gave you kind of a synopsis of where things have gone in terms of information theory. You can think of it probabilistically as well as either trying to sweep the field of chance hypotheses, that would be a kind of Fisherian approach to things, or of a more comparative nature, which explanatory hypothesis is superior and by how much? Can we quantify that? That would be a more Bayesian way of looking at things. These approaches are actually kind of interwoven with each other. So let me leap right ahead to this mess, okay? So this is a standard form of Bayes' theorem, with ID being the hypothesis that's tested, fine-tuning is the evidence, B is the background knowledge, okay? And what it's saying, essentially, is that what the Bayesian we call the posterior probability of ID, given fine-tuning and the background knowledge, can be measured and quantified if you know the prior probability. Now, what do we mean by posterior and prior? You don't think about it chronologically. I suggest you think about it explanatorily, which has explanatory priority. And it doesn't matter if it comes later in time that we discover it or whatever. what you're looking at is what is the foundation that explains something else. So, what is the likelihood? What's the posterior probability of ID given fine tuning and the background knowledge? It's equal to the prior probability it has given the background knowledge times the likelihood that you're going to see fine tuning on the ID hypothesis, all divided by that same quantity of the likelihood and the prior probability plus, and this is where we're seeing kind of an integration of Fisher's approach to the Bayesian approach. You've got to sweep the field of alternatives to the ID hypothesis. The probability of the falsity of the hypothesis given the background times the likelihood of fine-tuning given the falsity of the ID hypothesis, all right? So how do we go about making that comparison between ID and not ID with respect to fine-tuning? All right. Well, here's kind of a core fine-tuning argument for you. So you've got two incompatible hypotheses. Intelligent design, that the structure of the cosmos and its constants, its initial conditions, its laws, etc., are intended and directed, versus an undirected, unintended nature as the alternative. Now, it turns out that the likelihood of a life-permitting universe, that it exists as the result of unintended, undirected processes, is vanishingly small. And we're going to take a look at a couple of instances of why that is the case. So, the likelihood then that a life-permitting universe exists as a result of intelligent design is not vanishingly small. It's considerably larger, and therefore the existence of a life-permitting universe strongly favors intelligent design over undirected natural processes. Okay. Now, what can we say about the naturalistic hypothesis, the undirected hypothesis? Well, it's non-informative in certain ways. So what do we mean by that? Well, with respect to a set of outcomes, it gives us no reason to expect any member of that set. It's uninformative. It's uniform in that respect, whereas the design hypothesis might lead you to expect certain things to be present if the universe is designed for life. So it is not uninformative with respect to these considerations. All right. So what goes into the background? We need something fixed against which we can establish a measure for deciding how improbable something is. Well, the existence of the universe we're going to take to be part of the background, and I would say the nomological structure, the law structure of the universe, the laws of the universe. It's very difficult to try to establish a measure over the possible spaces of the different laws that the universe might have had. That it's not a well-defined sort of mathematical thing that you could do that with. So we'll take that as fixed, but that doesn't mean that we can't say something important about it that is kind of revelatory in and of itself. Okay, so what we're essentially doing then is thinking about a general philosophical, metaphysical question. Why is there something rather than nothing? Why is there a background against which we can make this measurement? And not to go into a lot of detail, but philosophically you'd want to say something like, well, there has to be an explanation for why there's a universe rather than absolutely nothing at all, and there has to be an explanation for why the universe has the laws that it does rather than being totally chaotic. Now, we can't establish well-defined probabilities for that, but we can say that one thing that seems certain is that we have to affirm a principle of sufficient reason, that things that could have been otherwise contingencies require explanations for being why the way that they are. If we don't have that principle, we wind up ultimately in a position of kind of epistemic nihilism, right? So if we say, suppose some things can happen for no reason at all. How do we know which things are happening for no reason at all? Even the things we take to have reasons for them might have been things that happen, in fact, for no reason at all. And there's no means that we can tell. What's more, there's no objective probability that we can assign to something that happens for no reason at all. So we can't even say that it's unlikely that it happened for no reason at all. So the hypothesis that there's no reason that something happened becomes a competing hypothesis for everything that we have to evaluate, and there's no way to evaluate it. What's more, consider your current state of consciousness and the thoughts that you're having. It's possible, if things happen for no reason, that there's no reason that you're having the thoughts that you're having right now. I'm not really here talking to you. This is just a random sort of thing that happened. No reason you're having these perceptions. Okay? So you open the door to an irremediable kind of skepticism if you reject a principle of sufficient reason. But once you've accepted a principle of sufficient reason and you say that there has to be an explanation, then it can't be something else that's contingent because that also needs an explanation. And you can't have an infinite regress of contingencies because the whole set is contingent. And so it has to bottom out in something that's necessary. And what can we say about that thing that's necessary? Well, it's the foundation of everything that's contingent, which includes all space, time, matter, and energy that did not have to exist. So it transcends that. It's timeless, it's spaceless, it's immaterial. What's more, it's given structure to what is. So it would seem to be something that is capable of acting, right? So it can't be something like an abstract object. Numbers aren't going to give rise to the universe. Numbers are causally inert, right? It has to be something that can act, and act with intelligence. And so we're already on our way to a kind of classical theistic picture once we've talked about a principle of sufficient reason being necessary to the background of what we're doing our evaluation on. All right. Well, what about the laws of nature? Is there anything we could say about the nature of the laws? Yes, of a general qualitative kind of observation. I mean, there are certain things like Bertrand's theorem that would point to the fact that it's necessary that we have inverse square laws, which require three-dimensional space or four-dimensional space-time. And there are other mathematical arguments to be made. Max Tegmark has made some that show that time has to be just in one direction. We can't have a universe with multiple temporal directions. It destabilizes things in such a way that you can't get information storage and processing working properly, and the existence of life would be impossible. And then there are various other things about needing gravity, a long-range attractive force in order to have stable platforms on which life could exist, and so on and so forth, if you're looking for embodied conscious agents and so on. So there are a variety of things that we could say about the law structure of the universe in general. So on that basis, then, you might want to say, well, all we're dealing with here is the higher probability before we even get of the background, when we, in relationship to the background, before we even get to cosmological fine-tuning. And on that basis alone, it would seem that the ID hypothesis is vastly more probable than its denial. All right. So, we're taking then the existence of the universe and its law structure as the background. So, given that, we can ask, well, what do we observe in the constants of nature and the strengths of the forces and so on as we try to evaluate the likelihood of a life-permitting universe? And with that restricted focus, then, we find that the initial conditions and values of the constants are extraordinarily finely tuned in a variety of ways. So, talk about the initial conditions of the universe. How fine-tuned did the Big Bang have to be in order to produce the universe that has the order that ours has? Roger Penrose did a calculation quite a few years ago now that looked at the observable statistical entropy of the universe. We have a measure of that that's an approximate, but good enough, and compared it to the range of order that the universe, or disorder that the universe could have exhibited emerging from the Big Bang, treating the universe, universal singularity as a black hole, and then using the Bekenstein-Hawking universal entropy, or entropy measure of black holes to quantify it. And it turns out when you take the ratio of the observed statistical entropy to the range of possible entropy, it's a rather staggering number. It's 1 over 10 to the 10 to the 123rd power. Okay? Now that's a number that's very difficult to imagine. It's hyper-exponential. It has more zeros in it than there are in elementary particles in the universe. Okay? In the denominator of that number. In fact, you'd need, if there are about 10 to the 80th particles, you'd need what? Maybe 100 million trillion observable universes our size just to write out the number with a zero on every elementary particle. Okay? Now, what's interesting about this is it's vastly more fine-tuned than it needs to be for life to be possible. What should we say about that? Well, Sean Carroll thinks that that's a problem. He was a theoretical physicist at Caltech. Now he's Homewood Professor of Philosophy, kind of got a Richard Dawkins-type chair over at Johns Hopkins University in Baltimore. He says the entropy of the universe, for example, seems much more fine-tuned than is necessary for life to exist. From a purely anthropic standpoint, there's no reason at all for God to have made it that small. So we therefore think there must be some dynamic physics-based reason why the entropy started off with the fine-tuned value that it did. Well, maybe it did, and of course theists are open to that possibility and would be interested in seeing that result, but at the moment there is no such physical explanation for this. And there's none on the horizon that would seem plausible. So what do we say in that? They can hardly criticize the theist for having an explanation that has some puzzlement about it, but is intelligible to not having an explanation at all. I think the point, though, can be made well by considering something that John Hawthorne and Yoav Isaacs called the totally awesome theistic argument. What if we had one of these? What sort of argument is this? Totally awesome theistic argument test. Well, suppose we found Genesis 1:1 woven into the structure of every atom in ASCII code somehow. Okay? In the beginning, God created. It's like kind of God signed everything. Designed by, well, you know who. So, would that be enough to convince us that God exists? I would think so, yes? That would be a totally awesome theistic argument. But now, suppose that we looked and we found the whole Bible in ASCII code imprinted that way. That's too much. That's too much. That's overboard. Well, that must mean then that we need to look for a physics-based explanation, right? No, I don't think so. So you take the point with respect to Sean Carroll's objection. All right. What other sorts of fine-tuning do we observe? Well, cosmological constant fine-tuning, expansion rate of empty space, expansion rate of the universe. We know that there is a cosmological constant that's affecting things, and we know that it's very small. And we know how small it has to be in order for life to be possible. So on a generous estimate, it has to fall in a range that's about 10 to the negative 90th on either side of 0. All right? If it exceeded it on the negative side, the universe would recollapse into a black hole in less than a second. And if it exceeded it on the positive side, it would be expanding so fast that it would basically become a uniform diffuse hydrogen and helium soup, and you wouldn't have any life, okay? So there's one factor, 1 over 10 to the 90th. What else? Well, the Higgs vacuum expectation value is also fine-tuned. So the Higgs field is what gives mass to things. And if its vacuum expectation value were different from what it is by about roughly 1 factor in 10 to the 33rd, you'd have an unstable hydrogen molecule that wouldn't capture electrons, and you'd erase the periodic table. So that's necessary for life. That's another factor, 1 in 10 to the 33rd. The coupling constants, the Yukawa couplings for the quark, the up quark, the down quark, and the electron are also fine-tuned to permit stable atoms and stars to about 1 in 10 to the 13th. And if we consider gravity itself relative to the strength of the other fundamental forces, the range of strengths of the fundamental forces is 40 orders of magnitude. If we allowed gravity to vary by 4 orders of magnitude, we would find that it would either crush life out of existence or it wouldn't allow things to hold together properly, in which case gravity itself is fine-tuned to about 1 part in 10 to the 36th. Put all of this together and plug it into our original formula down there at the bottom, we find that the posterior probability of the design hypothesis, given the fine-tuning that we observed, is approximately 1. It's a virtual certainty. Okay? So, I will leave things there. Now, there are objections. And I have a whole bunch of slides on objections, but we haven't got time. Need to turn things over to Doug.
With 20 minutes, John's going to give me a little extra, I know. With 20 minutes, I was thinking, should I try to unpack a scientific study? But it would take about 20 minutes to make one study intelligible. I thought instead what I'd do, this being EPS, is kind of give some conceptual arguments instead. So my official title for this talk is Design in Biology. Oh, somebody liberate more coordinates. Design in Biology and the Limits of Darwinism. As I put the talk together, I prefer this title, 3 Conceptual Takedowns of the Blind Watchmaker Thesis. So that's really what I'm going to be talking about. By conceptual, I mean it doesn't hinge on scientific data or scientific studies. And although I love scientific studies, I'm a scientist, there is benefit to arguments that are just clear common sense arguments that have to be true. Because then if a scientist says, well, I did this study and it shows that's not true, you say, well, then your study has to be wrong because this has to be true. So I want to give you a few of those. First of all, what is the blind watchmaker thesis? You've probably heard of Richard Dawkins and his book, The Blind Watchmaker. In that book, he says natural selection, the blind, unconscious, automatic process which Darwin discovered and which we now know is the explanation for the existence and apparently purposeful form of all life, has no purpose in mind. It has no mind and no mind's eye. It does not plan for the future. It has no vision, no foresight, no sight at all. If it can be said to play the role of a watchmaker in nature, it is the blind watchmaker. So I'm referring to that as the blind watchmaker thesis, but more broadly, I don't take when I'm referring to the blind watchmaker thesis, I mean any naturalistic account that replaces Paley's watchmaker, which is God, right? So it doesn't have to hinge on natural selection. It could be natural selection plus other things, because a lot of modern evolutionary biologists agree that natural selection is not sufficient, but they think that there's still a way for naturalistic evolution to work. So all of that I'm encompassing with the term blind watchmaker. And I'll use in this talk BW to mean that thesis, the blind watchmaker thesis. So here are, in bullet points, and I'll go through each one of these, what I consider to be 3 strong conceptual problems or takedowns of the blind watchmaker thesis. The first is it doesn't meet the usual standard of a credible scientific hypothesis, and that's a problem. The second is the physicalist conception of humanity is incoherent. I'm claiming there is no coherent way to understand us as being just molecular machines. And finally, the raw improbability of life, and this is touching on things that have been touched on before, the raw improbability of life by blind causes makes all such accounts implausible. And this is somehow not recognized by the people who make these arguments. So first, the blind watchmaker thesis doesn't meet the usual standards of a credible scientific hypothesis. Let me give you another hypothesis, which I think is credible. Doesn't mean it's true. And that is when you look in the night sky, you see stars and galaxies, and that raises the question, where did stars come from? Where did galaxies come from? And I'm going to give you a series of things that we know to be true, and then I'm going to give you the hypothesis for the answer to that question. And I claim this is a well-grounded scientific hypothesis, which doesn't mean it's true. It just means you're not crazy for looking into it carefully, because it asks to be tested. The first fact is that hydrogen is the most abundant element in deep space. There's a spectral line 21 centimeter radio telescopes detect, and that's the electron spin flip of hydrogen. You point that anywhere in the deep space night sky and you get this spectral line. That means there's hydrogen out there. That's a fact. Okay. The second fact is massive clouds of hydrogen are expected to undergo gravitational compaction. And that's just what gravity does. Gravity is mass attracting mass. So if the universe has lots and lots of hydrogen in it, it's not dense hydrogen, it's very rarefied. But if there's a lot of hydrogen there, then hydrogen will compact by being attracted to hydrogen. The third fact, and we know this is true, you can test, that's just gravitation. The third fact is under extreme compaction, hydrogen undergoes fusion to form helium. And this we know. This is the hydrogen bomb. We can put hydrogen in a device, tritium and deuterium versions of hydrogen, and using a prior explosion, using a fission explosion, we can generate enough heat and compaction for fusion to occur. That is what the hydrogen bomb is. And the fourth fact is that the hydrogen to helium fusion reaction gives off lots of heat and light. That's why it's used as a thermonuclear device. So all of these lead to, very naturally, this hypothesis. Stars and galaxies formed by gravitational compaction of massive clouds of hydrogen. It may not be true, but from what we know, it is very, very plausible. In other words, these things that we know to be true justify the hypothesis. Okay? Now, I want to compare that. Well, here's another way of saying that. Based on everything we do know, we reasonably conclude that stars and galaxies could have formed this way. Compare that to this hypothesis. This is Darwin's tree of life. That all, after some initial primitive protobacterium evolved somehow, Darwin claims to have explained how all of the millions and millions of varieties of life that we see around us occurred through natural processes. Now, what I'm claiming here in this, I've given this talk lots of times publicly, and I'm saying we can put lots of if I get all your favorite molecular evolutionists and evolutionary biologists together, ask them what are the facts that you would put here that you think add to the blind watchmaker thesis. Unguided natural processes, the blind watchmaker formed all of life. Now, we can list lots of facts up here. I'm not saying there aren't facts that have come out of evolutionary biology. I'm saying they don't add to this. And if someone thinks they do, I'm claiming they do not. If someone thinks they do, here's the chalk. Come up and give me your facts. I don't think I've given this challenge to lots of people. Nobody's taken me up on it. It's just a lame theory compared to what we consider to be strong scientific theories. It does not meet the basic criterion of a strong, justified theory. And if someone thinks I'm wrong, give them the chalk. Okay, second argument. That was the first argument. We got to roll through these quickly. I've only got 25 minutes left. Second argument. The physicalist conception of humanity is incoherent. Okay, there is no way to understand us as just being bags of chemicals. Okay, and to show this, I want to start with this principle. It's called the fallacy of self-validation. It's simply this: if the validity of X, whatever it is, if the validity of X is in question, then X cannot provide the answer. If you're not sure if Bob is an honest person, you can't ask Bob, are you an honest person? Oh, yes. Yes, that doesn't work. So if the validity of X is in question, you can't get the answer from X. Now, I want to apply that to this scheme, that human thought, we are thinkers as humans, and it's necessary for us to do thinking to do science, but it's also necessary that other things be true, that there's a world out there that we can study. And when we do science, we're aiming at an explanation of the natural world. Now, going back to this principle of fallacy of self-validation, if someone asks you, how do you know it's even valid? Or Bruce brought it up. How do you know you're even thinking? How do you know you even exist? Well, I can't through my own thinking show that I am thinking, right? Because if I'm not thinking, then I'm not. So the fallacy of self-validation works here. Likewise, suppose I am thinking. Suppose human thought is a valid project. That doesn't prove that there really is an outside world to be studied, okay? The matrix, okay? There could be that I'm thinking, and I'm thinking about coherent things about how things seem to be ordered in my conscious experience, but that doesn't prove that there is something out there that is real that I'm experiencing. So what we do, and we don't usually do this self-consciously, we just do it automatically, is we take these two things to be valid on faith and nothing but faith. I believe that I'm a coherent thinker. I can't prove that, but I take that to be true on faith. Having taken that to be true, I believe there is a world out there that has objective properties and that I can communicate to you, who I also believe are there, and we can do science. I have to take both of those to be true on faith because science can't validate science and thought can't validate thought. Well, we naturally do this. And then we embark upon explanations of the natural world. And I want you to consider, suppose we come up with an explanation that we call scientific, and it's considered to be standard understanding, orthodox understanding within scientific fields. It's in your AP biology textbook. All scientists are expected to believe it. But suppose the implications of this explanation, should it be true, would undermine our faith position in our ability to think. If that's true, then we should abandon that faith position. And having abandoned it, we would abandon science and we would abandon the explanation itself. So it's that would be a self-defeating explanation. Now, it turns out that the claim that brains think, that the gray matter, the neurons in your head are thinking, or doing your thinking, is just this. It's a self-defeating proposition. The way I run my students through this is I say, imagine that you're in a brain imaging lab, a futuristic one, where absolutely everything happening in your brain can be put up on screens in real time. You're conscious, they have probes around your head, and they're asking you, you're surrounded by these scientists who are sure that there's nothing but the material world. They're materialists, physicalists, and they're sure that your thoughts, therefore, are physical. And they're asking you to count and to think about the numbers. Count to 10, think about the numbers, so you start counting 1, 2. They say, stop right there. Your frontal lobe was activated when you said the word 2. Here's the image. Is this what you mean when you say 2? TWO. And you say, no, I'm not denying that my frontal lobe was activated. That's not what I mean when I say 2. They say, well, let's zero in. This particular synapse in the frontal lobe fired when you said 2. Is that what you mean when you say 2? And you say, you don't get it. I don't mean, there's nothing you're going to find in my brain that is what I mean when I use the word 2. I mean something conceptual. And then they get very angry and say, this is a physical world. There is nothing other than the physical. So if you mean anything at all, you have to mean something here that we can image. And since you're not agreeing, then you must be deeply confused. And then you ponder that. You say, well, if I'm deeply confused, if I follow the materialist by doubting my conscious experience, I'm forced to doubt absolutely everything. Everything. Why? Because I don't have access to anything except through my conscious experience. So if they're saying I'm wrong, they're saying I'm insane. And that means they don't exist, brains don't exist, science doesn't exist, I don't exist. It's all gone. Do you see how that's a self-defeating claim? So we're left with these two options. Either I am manipulating concepts, immaterial concepts, when I think that's what I think I'm doing, or the materialist claim is I am being manipulated by neurons. Physical things are giving me the impression that I'm doing something that I'm not. But this is manipulation in the positive sense. I am working with ideas. Do you see that? I'm crafting ideas. This is manipulation in the negative sense. I'm being duped, tricked, deceived. But if B were true, it's if you go in the direction of saying it's B, it self-destructs, right? Because if I'm duped, then everything's gone. Okay? And that leaves us with this conclusion. I am, in fact, manipulating non-physical concepts, which means I am not purely a physical creature. I have a physical body, but an immaterial mind, soul, spirit. And the Darwinian process, being purely physical, can't give such a creature, right? Because I'm not just physical. Okay, I've got 15 minutes left. Last point. The raw improbability of blind causes makes all such accounts the raw improbability of life by blind causes makes all such accounts implausible. And this is where there's a lot of confusion in the way evolutionists argue about chance. So I want to illustrate this. I'm going to give you a proof right here that we did not evolve by the blind watchmaker mechanism. Consider a lifeless Earth-like planet somewhere in the universe, okay? Thanks to AI, I can just say, give me a picture of it. There it is, okay? It makes talk so much easier. Okay, here's my question. How likely, so we're thinking about this planet out there somewhere, how likely is it that physical processes operating on that planet would produce a stone whose surface has letter-shaped indentations that form a coherent text hundreds of words long? Okay, I don't need a number here. What's your sense? How likely is it that physics, doing what physics does on this lifeless planet, will produce a stone with a text on it? I would say that's optimistic, but let's roll with that. 10 to the minus 74th. Okay, here I think our answer is the likelihood is so low that we rightly consider it to be impossible. Okay, and I think that's in the realm of that. So let's just call it this. We'll say P physical text is approximately equal to 0. So close to 0 that we don't really need to quibble about the difference. And yet, here's a stone for which proponents of physicalism give precisely this impossible explanation. Here it is. I've seen it. You say, wait a minute. That's here on Earth. Well, Earth is an Earth-like planet. And here is the process. Lifeless Earth, these people say, through purely physical processes became Earth with life. Through purely physical processes became Earth with intelligent life. Through purely physical processes produced a stone with hundreds of words of text on it. Okay? This is exactly what we said the probability is 0, effectively 0, right? Now, here's where people get confused. A common interpretation of this is with the natural evolution of humans, what was otherwise an impossible outcome became a likely outcome. So the evolution would say, yeah. On a lifeless planet, you're not just going to get a stone, but if you get intelligent beings that can carve stone, then you do get the stone. So this is the reasoning. And in math, they'd be saying this. This is conditional probability. So the thing on the left is, this says, the probability of getting the physics text given human evolution is roughly 1. Because if humans evolve and they have language and they can chisel on stone, then yes, it's going to happen. And the idea is that trumps the near zero probability, the raw probability of getting a text by physics. So this is our raw or prior probability. This is our conditional probability. And the thinking is that because that is close to 1, it somehow trumps the prior or raw probability. But that's false. That's absolutely confused. Let's think of it this way. Here's another example. You are the archer. We've already had an archer. Someone introduced us to our archer. I think it was Bill. You bring an archer blindfolded into a field, spin him or her around. They have no idea where a target is, and there's a target 200 meters away, okay? And you spin them around, and they say, take a shot. And what is the likelihood that they fire their compound bow and the arrow hits this bullseye 200 meters away when they don't even know which direction they're shooting? Well, I think we would all agree the probability of blind hit is close to 0. It's very close to 0. But someone might say, well, what about a conditional probability? Suppose the archer shoots the arrow and then wind takes the arrow whichever way he or she shoots it. The wind conspires to bring the arrow to the bullseye. So then probability of blind hit given helpful wind is approximately equal to 1. And that's true, right? If the wind did that, then yes, the probability would be close. But here's the problem. This requires more than just hitting a small target by chance. It also requires very special wind behavior by chance. So this is even less probable than just blindly hitting the target. And this is what people don't seem to understand. So the conditional here, P blind hit given helpful wind, that's close to 1, times P helpful wind. So this is the joint probability, the probability of wind being the cause of hitting the target, has to be much less than P blind hit. But P blind hit is close to 0, right? So this means that actually the probability, what this means is the probability of helpful wind is 0, right? And people invert this and say, no, if you get helpful wind and you hit the target, that's what it means. No, it means you're not going to get helpful wind, okay? So this is the actual case. P blind hit equals roughly 0 trumps your conditional. It doesn't matter what magic you want to, what story you want to give. It doesn't matter. The fact that the raw prior probability is close to 0 is what matters. And whatever story you want to give it is an implausible story because of this, okay? So more generally, P life by accident is approximately equal to 0. And I'm going to show you that Richard Dawkins agrees with this. Trumps P life by accident given helpful selection is approximately equal to 1. And we could concede, yeah, if you got all the right selective things that just happen just right, then yeah, you could evolve things. But you won't, because the raw probability is 0, which is how much time I have left. Okay. So the correct interpretation is the special conditions needed for an outcome that is beyond the reach of chance to become probable are themselves beyond the reach of chance. Okay, and they don't get this. For 150 years, they keep arguing, if I can tell a story to make this sound probable, then the story must be true. No, the fact that it's improbable means your story is improbable. Okay? Now, here's Dawkins conceding that the raw probability of life is close to 0. However many ways there may be of being alive, it is certain that there are vastly more ways of being dead, or rather not alive. You may throw cells together at random over and over again for 1 billion years, and not once will you get a conglomeration that flies or swims or burrows or runs or does anything even badly that could remotely be construed as working to keep itself alive. That's an acknowledgement that the raw probability is close to 0. He thinks, given selection, you get a conditional probability that's close to 1. Okay, if you get magic selection, all this means is that is the probability of that kind of selection is 0. It can't happen. Thank you.
Natural theology can be described as natural knowledge of God. That is, that there is a God and something of his nature, and that man is able to know that through reasoned observations of the sensible cosmos, and this without any commitment to religious tenets or doctrines. What I want to do here is try and place, if I can, or assess the place of the design inference as articulated by Dembski in his work in the history of natural theology. And I want to do that carefully, keeping in mind how Dembski has explained the design inference. On the theoretical side of things, I won't probably get a chance to get into some of this. I would love to talk about the metaphysics undergirding the design inference, but we won't have time for that today. So, it's worth noting immediately that the attempt to historically situate the design inference may appear to be thwarted to a certain extent by a suggestion made by Dembski in the years following the initial publication of his work. So this is what he says. This is from an article in Evidence for God. ID is more than simply the latest in a long line of design arguments. The related concepts of irreducible complexity and specified complexity render intelligent causes empirically detectable and make ID a full-fledged scientific theory, distinguishing it from the design arguments of philosophers and theologians, or what has traditionally been called natural theology. So there's a suggestion that maybe it doesn't fit into the question of natural theology. And I think there's a sense in which that's true. The design inference shows us the presence of intelligence, and it's not a question of a divine intelligence, it's just, is there intelligence? So before we historically situate the design inference, perhaps I may be excused if I provide some reasons to think that we can situate it within natural theology. Reason number one, and as we've seen today to a certain extent, it's already been situated. So in the design inference in chapter 1, Dembski and Ewart provide a short history of scholars inferring design from the improbability of events, pointing to people such as Cicero, Marquis Pierre Simon de Laplace, Thomas Reid, Abraham de Moivre, Ronald Fisher, and even Richard Dawkins. Later, they briefly describe the history of the concept of specified complexity, beginning with Leslie Orgel and tracing it through Paul Davies, Francis Crick, and again, Richard Dawkins. William Paley is also mentioned. We've seen him mentioned today as well. Another argument that we might present, and again, we've seen it today in the presentations, is that if the design inference only seeks to eliminate chance and necessity, such that the only cause of some effect can be intelligence, but that the effect in question is biological life and the cosmos, then the design inference would end up being something of a theistic argument based upon the data from the natural sciences. So there does seem to be a natural theological argument here based upon what we're dealing with. Finally, I believe that at very least, what we can say is this. Dembski's design inference serves to reinforce the key premises of at least one type of theistic argument, that is, the argument from design. So, first, quickly, we've seen the design inference described. I don't need to define it again. It's been extremely well described. Perhaps I could mention something about a designer or artisan, an intelligent cause that acting with purpose brings about a work of art, at least as far as an artisan is concerned. As Dembski and Ewart note in the second main section of their book, the main section of the second edition, their version of a design inference is used on a regular basis in our everyday life to eliminate chance as a cause, based upon the coalescence and the observance of the observed phenomena of low probability that an event will take place, and specifications are inferring, therefore, an intelligent designer. So where does it fit into the historical design arguments? This is what, first, in order to do that, let's talk about the types of design arguments that we find within the history of natural theology. So a consideration of the history of natural theology and the arguments demonstrating that there is a God allows us to recognize that design inferences are one specific type of theistic argument, distinguishable from other arguments such as the ontological argument, cosmological arguments, most of the five ways, for example, in Thomas Aquinas' Summa Theologiae, or the argument that we find in his De Ente et Essentia based upon the distinction between essence and existence. So we can distinguish it from those types of natural theological arguments. We then are able to discover three not entirely unrelated types of design inference. Now, as I was doing some research to try and do a taxonomy of design arguments, everybody's got their own taxonomy. And some people don't even make a taxonomy, they just lump everything in together. So I've provided my own taxonomy. Hopefully it's helpful. So there's three basic types. I'm going to work through each of them quickly. Type number one I'm just going to call this the teleological argument proper. This is based upon the observation of final causality. We find this type of argument in Aristotle and Aquinas. I'm going to take for the primary example of this, Aquinas' fifth way. It has taken a number of forms, but we find probably the clearest articulation of it in the Summa Theologiae Prima Par, where Aquinas it basically explains the argument this way. It's based upon the observation that within entities which are not endowed with intelligence, we observe that they are directed towards an end which they always or almost always attain. This end, or telos, is not voluntarily or rationally pursued by the entity in question. That is, the entity in question doesn't decide, taking the arrow example, if I put the arrow on the table and then say, okay, bud, there's the target. The arrow does not decide to get up and go. It must be sent by the archer. So it is not pursued or voluntarily or rationally by the entity in question. And yet, despite that fact, the entity always or almost always attains that target. Examples that one could give, at least from biology, would be things such as eyes and ears, which, though endowed neither with intellect nor will, always, unless inhibited, attain their proper end, which is the reception of light and sound. Aquinas suggests that if we observe such things, and we in fact do, then these irrational entities must be directed towards their proper end by something else, that is, an intelligent designer or artisan. Because that which lacks intelligence does not move towards an end unless it is directed towards the end by an entity which is itself endowed with intelligence. This intelligent designer, says Aquinas, is what most men would call God. The key premise of that argument is that which lacks intelligence does not direct itself towards an end unless it is directed to it by an intelligent being. This argument is based upon the Aristotelian notion of final causality. A final cause is one of the four causes described by Aristotle, which is necessary for understanding anything, from rocks that you find on the beach to the very complicated equations that we've been talking about today, which describe realities in the cosmos. For Aristotle, anything that in any way is has a final cause. That towards which the thing is by nature necessarily directed, both proximate and ultimate. And the proper understanding of anything will include its understanding its final cause. Our observation of final causality in beings that lack intelligence, from simple dirt to dolphins, demonstrate that these things are directed to those causes by an intelligent designer. That's teleological argument. There is another design argument called which we'll call the aesthetic argument, and there are in fact two forms of the aesthetic argument that we find in the history of natural theology. This is in fact at least from my studies, probably the most popular design arguments in the history of Western thought. We can trace this argument from Plato all the way up to the present day. The first version is what I'll call the Aristotelian Ciceronian argument from beauty, and the second type is what I'll call the hierarchical argument from beauty. For the sake of time, I'll just quickly outline these arguments and move forward. It's worth noting some scholars, in their rush to find a science-based argument in the classical argument from beauty, will sometimes latch on to this idea that there is complexity or structure being pointed towards, and then say this is a William Paley-style design argument. So in order to help us to better understand what's going on, we need to understand the ancient understanding or classical approach to beauty. Beauty is said to be found wherever we observe the confluence of three characteristics. Characteristic number one, wholeness or perfection according to the nature of the thing in question. Number two, proper proportion, symmetry, measure, or arrangement of the parts, again, according to the nature of the thing in question. And then number three is usually described as appropriate brilliance, light, or arrangement and display of colors, according to the nature of the thing in question. Note, in each case, each of these three characteristics, they are all determined in relationship to the nature of the thing that we are looking at. That is, in relationship to the form of that thing, of the beautiful thing. So whereas the teleological argument is based upon final causality, this argument from beauty is based upon formal causality. The Aristotelian Ciceronian argument from beauty takes those three characteristics thus enumerated and then argues that when we observe beauty, that is, when we look out into the world and we see wholeness, arrangement, and desirability, or brilliance, arrangement of colors in something, we recognize that these things are present in the beautiful thing because of an artisan. They must have been put there by an artist. This argument, I think, is very similar to what we find in Dembski's design inference, both in the connection made with the order and arrangement and structure, and also in the fact that Cicero claims that the observation of beauty leads us to deny that the cosmos was caused by chance. And so it has two of those aspects that we see in the design inference. One potential difference here is that Cicero does not appear to be interested, at least in his formal articulation of the argument from beauty, in specified complexity. Rather, if there is beauty observed, he just says it's due to the imposition of the form, the nature of a thing, upon matter. Matter is not informed, but rather deformed by chance, unless an intellect poses form from without. As such, the observation of beauty, according to a form, demonstrates the existence of an artisan. Natural beauty, therefore, is evidence of a divine artisan, and when the beauty observed is at a cosmic level, in Cicero's work on the nature of the gods, he suggests when it's at a level which is beyond the ability of man to create, such as the cosmos, the movement of the planets and stars, is how he would describe it, it is even more evident that it must be made by an artisan of cosmic proportions, transcending the cosmos, a divine artisan. I'm going to I'm going to mention briefly the hierarchical argument from beauty. The hierarchical argument from beauty is found also in Aquinas' Summa Theologiae. It is the fourth way. This one is somewhat controversial. In the Thomistic literature on the subject, you will find just about every opinion on what the fourth way is doing and whether or not it's valid or not. I can't get into the details of it because of all the debate, so I'll just summarize briefly what's going on. And I would like to note, it's technically not a design argument. Aquinas' fourth way does not arrive at the conclusion, therefore there is a designer. It arrives at the conclusion, therefore there is a beauty which is supreme, from which all beautiful things derive their beauty. And he does not arrive at the conclusion, there is therefore a designer. So technically it's not a design argument. It's based upon a hierarchical comparison of beauty. This thing is beautiful, this is more beautiful, and we are able to move all the way up. At some point there must be a first from which all beauty derives. Arguments from beauty have a long and noble history in human thought. And in fact, I would suggest that you can almost be guaranteed that any time prior to the scientific revolution that you find a scholar suggesting that the order, structure, perfection, or beauty of the cosmos demonstrates that there is a divine artist, you are looking at an example of the Aristotelian Ciceronian argument from beauty. Number 3, this third form of design inference. This is a design inference which I'll call the complexity version, based upon observed complex structures. We've already talked about Paley as one of the most important proponents of this argument, not the first, but certainly one of the ones that's most associated with it. With the advent of the scientific revolution and the rejection of formal and final causes in the natural sciences, a new type of design inference gains popularity. That is an inference from observed complexity, fine-tuning, and so on. The most well-known example is William Paley. Quickly lay this out for us. In William Paley's work, Natural Theology, published in 1802, he argues that if one's walking in the country and one stumbles upon a rock, there would be no evidence that was placed there by an intelligent designer. Even if it may have been the threshold of a household at some point, stumbling upon a rock in a field is really not that improbable, if we could put it that way. However, if in walking in the forest or in the field, you find a watch. Actually, let me put it this way. We have a forest behind my house. When I'm walking in that forest and I stumble upon the metallic remains of what used to be a bed or a mattress, we come to the same basic conclusion here. It doesn't even have to be a watch. He says if we find a watch, the only possible inference would be that it had to be created by an intelligent designer. The reason why an intelligent designer must be inferred from the discovery of something like a watch, according to Paley, has to do with the intricate complexity and organization of its parts towards an end. He says this in his second chapter of his Natural Theology. Quote, "There cannot be design without a designer, contrivance without a contriver, order without choice, arrangement without anything capable of arranging, subserviency and relation to a purpose without which there could intend a purpose, means suitable to an end, and executing their office in accomplishing that end, without the end ever having been contemplated or the means accommodated to it." His conclusion is the following. The inference we think is inevitable that the watch must have had a maker, that there must have existed at some time and at some place or other an artificer or artificers who formed it for the purpose which we find it actually to answer, who comprehended its construction and designed its uses. De Cruz and de Smet, in their work, A Natural History of Natural Theology, they suggest that Paley's argument is a form of argument to the best explanation that relies on an inference to the best explanation. As such, it is an argument based upon probabilities related to the production of complex things that are end-directed. So having considered the three main types of design inference, let me just now situate the design inference within those three places. I think it's fairly obvious, if I could put it that way, where it fits within these design inferences. It is almost identical in form to that which we find in William Paley's work. Okay. Why is it not the first one that we talked about? Though the third type of design argument appeals to teleology, it does so in a way which is much more restricted than the fifth way in Thomas Aquinas, or at least it appears to. Though Paley does appeal to teleology, he seems to base his understanding of teleology upon our ability to recognize a complex arrangement of parts which is imposed from without towards a specific end. Whereas for Aquinas, everything that in any way is, whether it's complex or not, is endowed with final causality. You find a rock on the beach. That rock has a final cause. The fact that it has a final cause shows that there is a divine artificer. And so there's no question necessarily of complexity at all within that particular argument. I'm going to move quickly forward here. Secondly, Paley's argument is an inductive argument based upon probabilities, whereas Aquinas' fifth way is typically presented as a deductive argument, arriving at a necessary conclusion. Finally, there does not appear to be in Aquinas' fifth way any analogy. I don't believe there's an analogy I don't think there's necessarily an analogy between design and human rational activities with creative entities, but there definitely is no analogy in Aquinas' as well. On the other hand, I'm going to skip that. I've got a minute left. I would suggest that there's a sense in which we can distinguish it a little bit from the Aristotelian Ciceronian argument for the simple fact that the Aristotelian Ciceronian argument is looking at formal causality specifically, though I do think, and this is one of the questions I would love to hear Dembski talk about, is what do we do with formal causality as a metaphysical principle, and can we use that as information in the design inference? If we can, then we could probably use the Aristotelian Ciceronian argument, and there is in his book Being as Communion an allusion to the idea that even the arts can be analyzed by the design inference, though it's not developed much. I would love to see that more developed. It's worth noting, and I'll just conclude in this way, sometimes within recent literature, some Thomists have been somewhat upset for some reason with Dembski's argument. Some of the reasons, I think, have to do with the fact that they've been slow to recognize the persuasive power of this argument, specifically for those who are involved in the natural sciences. There may be, secondly, the metaphysics undergirding the arguments may seem to many Thomists difficult to reconcile with the Thomistic metaphysics, and that for them seems to be a flaw. However, Robert Koons and J.T. Bridges have suggested that we could possibly ground the design inference upon a Thomistic Aristotelian metaphysics, which would then, I suggest, make it plausible for Thomists as one version of a teleological argument that works, in fact. I'm going to stop. I've got lots more.
For anyone to answer, but this might lean a little bit more with Doug. So in the secular world, it seems like the academic quality of people defending Darwinism has decreased. Professor Dave on YouTube, who's not a professor, is one of the examples. And there's the Professor Dave example on one end, and yet I see that there's qualified researchers who are openly voicing their doubts about Darwin. Do you see a paradigm shift coming in the secular world that might acknowledge design?
Yeah, that's an interesting trend, because if you go back a couple of decades, you had the rise of the new atheists, and it seemed like there were a number of qualified academics. I mean, going back to the Richard Dawkins era, who he hit his prime, I don't know, in the 80s, maybe the mid-80s. It seemed like you had a lot of academics who were willing to say, yes, I'm a true Darwinist, neo-Darwinist. There's an interesting meeting convened in London by the Royal Society in 2016 that I was at, and I don't know if anyone else on the panel was at. Were you there, Bruce? No. 2016, no. And it was called, I don't remember what it was called. It was like new approaches or new thinking on evolution. And it was a bunch of these people who called themselves the third way. So they tend to be younger scientists who are disenchanted with Darwinism, who think it doesn't work, who have all kinds of reasons, good reasons, to think that natural selection is not the blind watchmaker. It's not going to do anything remarkable. But in the mix, there were a few of the old guard. Dawkins wasn't there, but a guy named Graham Bell, who's a classical gradualist selectionist, was there. And the old guard was saying, you're throwing out all these complaints, but stop your complaining. You're badly behaved children. Get back in the camp, because basically it's all about Darwinism. But to me, that meeting and the fact that it was convened and it had so much firepower on the non-Darwinian side does represent a shift where a lot of the thoughtful people are no longer willing to say, I'll defend the Darwinian orthodoxy, and you end up with people like Professor Dave, who is really not an expert at all, being kind of left defending the fort.
Okay, one more question from me, then we'll maybe let you guys ask us some questions of each other, and then the audience can throw in. Do you have any worries that some feature that today we call designed, and point out, is someday going to be found to have a naturalistic explanation? If not, why not?
I think part of it is just I've been at this game for about 30 years, and if anything, the problems seem to be becoming more and more intense on the other side. So it's not as though the problems of complexity are dissolving once we look deeper into things. I mean, you go back maybe 2 decades ago, and there was this thought that the inverted retina on the mammalian eye is badly designed, okay? And then you find that there are these glial cells, Muller glial cells, that act as fiber optics that then focus the light and make this system work much better. And so it just seems the complexities just keep getting better and more intensive, and there's more for the Darwinists to explain. I mean, the whole junk DNA business of the early 2000s is dead. I mean, after the ENCODE project and all the things that you find, that all this supposed junk DNA does seem to be functional. It is being translated into microRNAs. Doug can speak much more to that. But so there's this momentum, it seems, that the problems aren't going away. It's not just that they're not going away, they're becoming more intensive. And then if you do probability calculations, run specified complexity arguments, there's just a lot more stuff to apply them to. And so I mean, I would say it's a question of momentum. Now, anything could happen, right? I mean, we plumb, we go still deeper and deeper, and then suddenly things become simple in some way that we didn't suspect. But you can't build a science on things that are unexampled and totally unsuspected. You have to go with where you are, and that's where the momentum seems to be.
Okay, do you guys have any questions for each other?
dug this argument of you're shooting an arrow at random, and then you get the helpful wind, and you're doing a based theorem type argument there, or conditional probability argument, I should say. That has very much of a conservation of information feel, where you're basically filling one hole by digging another. And how much have you developed that? And it seems that there are two prongs to your approach. I mean, one is, are these more commonsensical, let's just take down Darwin in ways that everybody can appreciate, but then you also have your own more nuts and bolts molecular biology work. How do you see those relating, and do you see one as more powerful than the other? Are they complementary? How do you see that?
So yeah, I've spent decades doing experiments that are looking at the information content in genes, publishing papers, looking at first at the difficulty of getting a polypeptide chain, a chain of amino acids to have the right properties to fold and form a functional enzyme, and then with others looking at the difficulty, given one of those, of changing its function from, say, function A to function B, and a number of other things. And every time we look, we reduce the magnitude of the challenge we're putting to the Darwinian mechanism, and every time we find that it even fails that one, and we have to go lower and lower. The most recent, this is a computational biology study, was the question, in a small population, does natural selection have enough power to retain existing genetic information? And we did a model of 1,000 simple bacterial cells, and found that it crashed. It couldn't even retain what it had, which I think that was kind of, I can't think of anything lower than that. So every time we put Darwin's theory to a test, it fails. But I do come back, and this connects to the approach for writing my book, Undeniable. Whenever you make a scientific argument and it gets some traction, and it's an argument against the orthodox Darwinian or naturalistic view of life, it's not a question of whether it will be criticized. It will be criticized. And I came to realize, after the Lord called me to this work, and I first thought it was strictly a rational problem, strictly a scientific problem. And if you get the right data, you'll convince everyone. And I became convinced it's a spiritual problem fundamentally, and that people don't want to go somewhere. And if they badly enough don't want to go somewhere, they won't go there. And they'll come up with whatever reason for not going there that they can. So that's really what drove me to think about, well, okay, you can have technical arguments and people won't like where they go. They won't go there. There's a beauty to a non-technical argument, a commonsensical argument, because everybody can get it, and they don't have to have a doctorate, and they don't have to do experiments. And so I really like finding those best arguments that are not technical, that you can actually describe to anyone. And with a little bit of thought, I like to equip people with those arguments, because if you stay with the, genetic experiment type of argument, then someone who's not in that field, they can say, well, so-and-so says this, and they did a study on it. And it's so easy for someone to say, well, so-and-so trashed that study and they did another study. So it's I think there's a lot of power in commonsensical arguments.
All right. This one's for Dembski. Okay. And I raised this in my presentation. This was the question that I was referring to in relationship to the Aristotelian Ciceronian argument from beauty. So I'm, for the sake of everyone else, I'm going to quote to them what you wrote, and then ask you to kind of elaborate, if that's okay. Okay, so in Being a Communion on page 188, you say this: speech acts broadly construed are able to characterize how intelligences create information quite generally. In our experience, information is created in any number of ways. Painters create information by applying dabs of paint to canvas, sculptors by chiseling away at stone, musicians by writing notes on lined sheets of paper, engineers by drawing up blueprints, etc. Yet in all such acts of information creation can be represented in language. And so the question that I raised was, I wonder if, assuming that design inference can use the information in a work of art, for example, Botticelli's Birth of Venus, Da Vinci's Mona Lisa, or even something like a work by Salvador Dali, to detect design, could it also use the beauty of a sunset or a sunrise, of a landscape, of trees or wildflowers swaying in the wind, or a long and uncluttered beach or ocean-side cliff to detect design?
So you want an argument from beauty out of specified complexity or something like that. I'm not sure you're going to get it. I mean, it's, I think it may just be too broad a brush to get that, because, I mean, you can just imagine, with a work of art, Michelangelo's David, and then, one of his students gets and botches it. I mean, still looks human. I mean, it still is designed, but the beauty is lost. So there's a sensibility there that I think goes beyond what, I think it's too blunt an instrument, specified complexity for beauty. I mean, I wish I could say, oh yeah, it'll work, get more mileage out of my program. But I think there's a limitation there. But that said, I think that's why Aquinas does it as still one of his ways. I mean, it's another avenue, and I think it's very powerful. It can be open up people to dimensions. I mean, because there is going to be, design is presupposed in beauty. I mean, but it goes well beyond that, and so it's, I think, something that can reach people in a way that just a technical design argument may not. You're familiar with Thomas DeBay's Evidential Power of Beauty. I mean, that's a Catholic priest that he wrote an entire book on that. So it's, so I think there's much to be said about beauty and drawing people, but these arguments, I'm repeating myself, I think there's a technical aspect which doesn't quite get there.
So questions from the audience.
I think it was clear from Bill Dembski and others that complexity alone, improbability, isn't enough to show design. If you flip a penny 1,000 times, the particular sequence you get is 1,000 bits of information, but that doesn't really show anything. And so I think, Bill, you were adding that you have some short description of the result or of the process, and the fine-tuning was adding some implicit teleology, a purpose of making things a universe that man can live in. And my question is there a place for the idea of meaning? And I'm thinking of John Lennox's argument, I've heard him use a few times, where you see a bunch of scratches on the wall, and you think that's just random from some stick. And then your friend comes along and says, oh, no, that's a Chinese character. All of a sudden it has evidence for design because there's meaning behind those scratches. And how would you incorporate that into the design arguments?
The fundamental notion behind information is a narrowing of possibilities. So I'm on planet Earth. Well, I couldn't help but be on planet Earth. You haven't learned anything about me unless, once Elon and NASA get their act together, maybe, then that would be informative. But if I say I'm in the United States, I've narrowed things down. If I say I'm in San Diego, I've narrowed it down further. If I say I'm at the Marriott Marquis in the Marina in San Diego, I've narrowed it down further. So I'm giving you more and more information as I narrow things down. Semantics is a way of narrowing things down. I mean, we can linguistically, if I say it's raining outside or it's not raining outside, if I look at that linguistically, it has a certain amount of meaning. It's narrowed down out of all these different possible symbol sequences. It's narrowed it down. Semantically, it's narrowed down nothing because it's a tautology. It's raining outside or it's not raining outside. So information always needs to be understood in with relation to a reference class of possibilities, then a narrowing down of them. So a semantic view of information falls under this broader view of understanding of information. Improbability, sheer improbability is never enough because highly improbable things happen. And it's remarkable that it seems that even to this day, people make this sort of as a counter argument to intelligent design, that as well as you're just saying that it's so improbable and therefore it can't happen or it needs design. No, we never said that. So improbability needs to be there because if it's too probable, the example of somebody sending us the indefinite article in Alien, but we would not know it. Because we need more complexity, we need improbability. So it's a necessary condition, not a sufficient condition. And then you do need a recognizable pattern. But what is it to say that something is a recognizable pattern? At that level, it's purely subjective. To make it objective, we bring in this idea of Kolmogorov complexity. And it seems to match up very nicely, handles really everything we need scientifically. I mean, we're here at EPS meeting. It's a philosophical meeting. Under the auspices of Evangelical Theological Society. Design inference, I see it fundamentally as a contribution to the foundations of probability and statistical theory. So I think it's a statistically sound approach to things. That said, when I wrote these ideas up initially, it was within the philosophical community. I mean, the paper that got all this going for me was Randomness by Design. That was published with Noose, which is a premier philosophy journal. And then Design Inference was in a monograph series, but it was a philosophical monograph series with Cambridge University Press. So the math is essential, but there are also then broader philosophical considerations to try to bring this all together. But this idea that you need something in addition to improbability, I mean, it's kind of like, we do this in philosophy where it's like, we know, true belief is necessary for knowledge, but there's still something else, just justification won't do it because we've got these ether examples. And so Plantinga develops a notion of warrant, Improbability isn't enough. We need something else, okay? We're going to call it specification, okay? But unless we fill that out, it just becomes a magic word, okay? Specified complexity, that gives you design. Well, but what is specification? But then it seems that after a lot of hard practice with these ideas, the idea of minimum description length, the Kolmogorov type notion of specification seems to be exactly what we need. It seems to handle functional complexity. It handles all these cases that we need. It has scientific credibility, and it makes for a unified information measure that merges Shannon and Kolmogorov information. Those are the key notions of information. If you go to an information book, and it brings together this idea of event pattern duality because events are out there in the world, and yet we describe the events. And if we can describe it simply, but the event is improbable, that's the type of match. It's a royal flush. Royal flush, very simply described, very improbable. And so that's the idea.
I'd like to hear some of those non-technical arguments for design.
What I mean is, I could have got up here and talked about molecular biology, but then I'd have to introduce all these terms. It would have taken 20 minutes to do one talk about one experiment. So the three conceptual arguments that I gave are non-technical in the sense that you don't have to you can understand everything you need to know how those arguments work. Now, when I teach these to my students, I call them common science arguments, right? Connecting to common sense. But I preface that by saying, I'm not saying they're easy. I'm just saying you're qualified to get them, okay? They're not easy arguments, but everybody's qualified to work with them. And once you understand them, you can use them. That's what I meant.
Just by and large, I think you guys have done an awesome job over the years in making a very compelling case that there is a designer. So my question is, seems like there's a logical next question. I'm curious as to whether you or anybody is doing work in explaining not necessarily that there's a designer, but how did that, given that you've shown that there is a designer, how did that designer do his or its thing, its design? I'm interested in how did that information get injected that then resulted in what we see?
There's some interesting things to be said on that, but the bottom line is there's a lot that we don't know. One interesting thing is, have you read Michael Behe's book, Darwin Devolves? Okay, so I would say that's an interesting, so let me summarize the hypothesis. He uses the polar bear as kind of an example and compares polar bear, Ursus maritimus, to brown bear. And he says if you look at the genetic differences between polar bear and brown bear, there's a handful of them. And in most cases, they are breakage of genes or loss of function changes in polar bear compared to brown bear. So the idea, which I think is quite credible and extends beyond just that example, that perhaps God created genetically rich kinds with the potential for them to radiate in different directions and occupy different niches on the planet, depending on, where they go and what they eat and that kind of thing. And they shed a little bit of genetic information on the way. And in doing so, they become different looking and adapted to different niches. Polar bear looks quite different from brown bear. Polar bear eats a largely blubber diet. Brown bear has to be able to eat animals and berries and all kinds of things. Polar bear has white fur, brown bear has brown fur. But in radiating that way and specializing, it's a one-way trip because you've broken genes to get there and to specialize, and therefore you're not going to go back. So that's an example of how might God have done it. It doesn't, some people are looking for what would it look like if we had a videotape running, and I think that's a much harder question to answer. But what might the strategy have been? I think Behe's onto something with Darwin Devolves.
By the way, that fits the fossil record because as they get more specialized, their odds on going extinct greatly increases, which is what you see. So, yeah.
Well, to that last question, we know at least historically there's one case where God did insert genetic material, and that was in the incarnation. My question to you is kind of the flip side of what you said, Douglas. I mean, most people here will accept some level of evolution, disagreeing over whether it's species, genus, family. But the fossil record would seem to indicate that life is extraordinarily adaptable, can react to environmental changes and survive, has survived geological catastrophes. What if God engineered life to be adaptable? Kind of the reverse of what you said, loss of genetic material. What if God had engineered life to be adaptable? And wouldn't that even require a higher level of design, a higher level of engineering than just what's been discussed so far?
No, what I'm talking about is adaptation. The fact that all I'm saying is if it's conceivable that God created kinds that have extra genetic modules, if you will, that are there for occasions that may or may not be realized in specific genetic lines. So down one line, it might specialize in this way, in which case it loses these things. If it had gone this way, and its cousins may have gone this way, it loses different things to become specialized in this. So that is adaptive, that is evolution. But Behe's point, and I agree, is that doesn't explain the origin of genetic information. It's a pre-organized thing, and it's just realizing its different outcomes. Okay?
I think most cosmologists today would say that eternal chaotic inflation is a perfectly good mechanism for generating a multiverse, and a large enough multiverse explains fine-tuning and almost everything else that everyone was talking about here. So that's an objection you didn't get a chance to talk about. What do you say about the multiverse?
The idea of an endless generation of bubble universes was initially hoped actually to be able to be eternal in both directions, that it would be beginningless. And that was pretty much foreclosed by the work of Arvin Board and Alan Guth and around 2003 or so. Bordguth and Alex Valenkin as well. But there are some interesting problems with the inflationary model. I mean, it's widely accepted. A lot of people think that it's basically got some things right. It does explain the scale and variance distribution of the cosmic microwave background and various other things, although it's not the only approach that does so. The difficulty, though, is that it has to be fine-tuned in a variety of ways itself in order to generate universes like our own. It has to be fine-tuned so as not to break down as a process. It also increases, for instance, the entropic fine-tuning, the initial entropic fine-tuning at the beginning of the universe. So inflation is an entropy increasing process, at the end of which, at the beginning of our universe, it's fine-tuned to 1 part in 10 to the 10 to the 123rd. You've just exponentiated that again by putting inflation in front of it. And the idea is, well, you get so many universes that maybe even you wipe out that improbability. Once you've gotten that far, though, you've gotten to the point where you're dealing with things like the Boltzmann brain problem and the issue that anything that can happen does happen, so we can't put a probability measure on anything happening or make predictions about what should be the case on the basis of our physics. So what I would say about inflation is that, well, if it is a naturalistic mechanism, it's one that destroys the possibility of scientific rationality. Ultimately, the evidence for it is somewhat equivocal. It involves fine-tuning itself, which in some cases digs the hole deeper on the issue than it was before they invoked it. And as a naturalistic explanation for things, still in the background, you've got the questions of why is there something rather than nothing, and why does it have the structure that it does? Okay, so maybe inflation has something to say for it. Maybe it doesn't. I'm a bit of a skeptic with that in that respect, and some of the recent work of Paul Steinhardt and Anna Aegis and others criticizing the model, when Steinhardt was one of the people that initially contributed to its development. I think that they have some a genuine point about slow roll inflation, for instance. It has to be fine-tuned in terms of the plateau where it drops off in order to wind up with a universe like our own. And so there's some gerrymandering to it that is pretty evident as well. In fact, the physicist William Unruh years ago said that he could fit any dog's hind leg with inflation. What kind of universe do you want? And I'll give you the model that'll give it to you. So how much explanatory power is there when you can adapt it that readily to whatever you need? So,
can I say a couple of things to that as well? I think there are two severe problems or refutations of the idea that what we see here can be explained by a multiverse. And one is combination multiverse and anthropic principle is thought to explain how could we come to be asking where we got here. Well, however improbable it is for intelligent life to have evolved, if there's an infinite number of attempts at it, it will have succeeded somewhere, and that somewhere would be where people are asking, how did we get here? But that doesn't explain why there are 6,000 species of ladybug on planet Earth. That doesn't explain the full profusion of life. What that gives you really is an acknowledgement that all life is extremely improbable, and you would expect to get the bare bones path to a thinker by combining an infinite number of an infinite multiverse with the anthropic principle, it would only explain the bare bones minimal path to a thinker, because that would be by far more probable than a profusion of life that we see here. So what we see when you look at planet Earth is not bare bones. So do you get why that does not fit with the multiverse, right? Because anthropic gives you the bare bones. You're acknowledging that this is a way to get around extraordinary improbabilities. So you're not going to get anything more than what you absolutely need to get a questioner. Okay? You're not going to get 6,000 species. You're not going to get all this profusion of life around us. That is not explained by multiverse. The second thing is I gave you an argument for how it's incoherent to understand us in purely physical terms. It's utterly incoherent. A multiverse is a physical system that cannot come up with a non-physical aspect of a human being. So it fails in that regard as well.
Second problem you raised, you talked about naturalism's inability to justify itself. And that makes sense to me. But then you pulled in faith as a way to justify thought. And it seems to reduce all knowledge to faith. So you have to have faith in your knowledge. And I can see that kind of working with the naturalism argument, and that, like, if you ask, like, how are all natural facts explainable? And you say by natural facts, it doesn't work. But if you ask me, how are you thinking? I would just respond, or how do you know you're thinking? I would just say, because I'm thinking right now. I don't see if it's quite the same thing. Does that make sense?
Yes. So what I would say, I actually give my students an argument here that starts with, consider this proposition. Here's the proposition. I am completely insane, utterly incapable of coherent thought. That's point one. Point two, any attempt to refute that proposition will require me to think. Point three, any such thinking is invalid if the proposition is true. Point four, therefore I cannot refute the proposition. Point five, therefore all thinking must start with the faith position that I am capable of coherent thought. So that's basically an outline of how you cannot get to thinking without a faith position. And you're absolutely right. I am saying all human knowledge is grounded in faith.